Let's assemble this 2-element phased array kit by Performance Z Arrays. But first I want to be honest and transparent with you. The owner of this company, John, NJ4Z, is a good friend of mine. He gave me this kit and said, be brutally honest. I want your feedback. And that I intend to do. But I don't want you to take my word for it. I'll assemble it, then we'll put it on the air, and I'll let you be the judge. So let's get into it. So in the controller part of the kit, you get this nice aluminum enclosure. That's a good quality printed circuit board. And you have custom plates for the enclosure, nicely marked up. What I really like is metal buttons and switches. No plastic in this kit. So we'll start out by putting the board in the vise. John had a really good suggestion about using blue painter's tape to hold the parts in place when you're assembling it. That way when you flip it over, they stay right there. I always like to solder the outer legs and make sure the parts in there straight before I continue. Now we'll solder the rest. It's always a good idea to inspect all your solder joints to make sure you got good connection. It's always good to look everything over one last time. Now what I like about this kit, since John provided these connector blocks, instead of soldering wires directly to the board, this makes it more serviceable in the future in case you have a switch failure or something like that. Now that we've finished soldering the board, we can move on to the controls. I need my glasses for this one. So first I'm going to start with the power switch, and I've mounted it in the vise. And for that we'll need the red, black, white, and blue wire. We'll go ahead and strip a little bit back from each one. Twist it. And then we need to tin each wire. To tin the wire, you just put a little bit of solder on the wire. Doesn't need much. The red wire goes where it says CH. I stick it through the hole, solder it in, and then trim off the other side, the extra. And there you go. Don't know if you can see that well. Then the white wire goes on the negative. Trim it as well. I'll keep working around. Next will be the blue wire, which kind of looks purple to me. But I don't know colors, ask my wife. And then the last wire is the black wire. And there we have it. When you're done, you should see the red wire at top, the white wire, blue bottom at bottom, and the black wire. And that would be going clockwise. Now we'll use the front control panel and start mounting the controls in it. So on this switch, you want to find the center section. And that should go straight up in the board pointing to broadside. Now we'll insert the power switch. If you don't have a vise and you're soldering this together, you could attach these to the board and then solder to them by just setting it down. Next, we're going to put the 3 LEDs in it. insert the plastic grommet, which is honestly the only plastic in this kit, and then stick the LED in from the back side. Then we'll take the plug, you should see the spring clip. There's a notch on the board that line on the control that lines up. And it should just push on. It takes a little bit of force, but it should just push on like that. And there you go. We have a upside down. And there you go. We have the completed front control board. Now we'll work on the back board. To make it easier to hold, I went ahead and mounted it in the board. And now I can set the board in my vise. Now if you look at that plug, you will see pin numbers on the back side. Now we'll be using the other half of the 4 wires from the earlier control and the green and brown wire for the controller plug. We're going to do the same, strip the ends on those. You want to put a little solder on the pins to begin with, but don't let them get too hot. Then give each wire a little tug, make sure it's on there. And now's a good time to double check to make sure that you got the correct wire on each pin. So pin 1 should be red, pin 2 should be black, pin 3 should be green, pin 4 should be white, pin 5 should be blue, and the center pin, pin 6, should be brown. Now we'll take the power connector and put it on the board, just like so. Now we have both boards done, ready to assemble. So the board will slide right into the case through the notches that are there. Then you'll see the side with just the 2 connectors is where the back panel will go. What I like to do is just finger tighten these screws until I'm completed. Now I'm going to hold the board about halfway through and see how much wire that I need to cut off, because I would like it to be pretty perfect, but you want a little bit of slack, so I'll take it and bend it just so I have enough slack. And then I'll cut off the excess wire. I like to keep it clean and neat, not have a bunch of wire loops. Strip all my wires, twist the ends, and I'll do the same for the power connection. And now you'll see on the board that it's marked pin 1 through pin 6, and it follows the same order as the connector. So we'll insert the red into pin 1 and tighten it down first. Then black goes to pin 2, then green for pin 3, white for pin 4, blue or lavender, I guess, for pin 5, and there you go. Of course, red's for 12 volt DC, and black goes to DC ground. And there we go. The back panel is connected. Now I want to do the same with the front, so I don't have all this excess wire. So I'll measure it out with a little bit of excess. We'll cut that. Now the selector switch is so big, we are going to have to loop it. But we could loop it just like so. Just like a little kid. And we'll measure out for our LED wires. And trim them as well. Now we'll strip all of those again. Now the only part of this build that could be a little confusing is this plug on the selector switch. You will find that there's a positive side and a negative side. And to identify that is if you look straight down the switch, if you look straight down the plug, you can separate it so you see green, white, and blue line. And the side with the red wire is your positive side. The side with your black wire is your negative side. So this time, to make it easy, I'm not going to screw the front panel down. And we're going to start making the connections. And the first connection is the LED positive, which is the red wire. So I'm going to insert that where it says LED positive. The next wire is the C positive. And what I want to do is do all the positive wires at one time, since they're already split in my hand, so there's no confusion. So the next one is the NC positive, and that's the blue wire. And then it's the NO positive, white wire. Now I'll double check my wiring, and you can see the plug is split down, and there's all my positives. Now we'll go through and connect the negatives. So we'll start with the LED negative, which is the black wire. And then we'll do the C negative, which is the green wire. Sorry, I keep bumping this little camera here. We'll do the NC negative, which is the blue wire. And then the NO, which is the white wire. Finishing off with what looks like that. Now I'm going to do the LEDs next. So if you look at your board, element 1, broadside, in element 2, marked as E2 and E1 respectively. And if you look at your control board, they are marked on there as well. So the positive is the red, black is negative as usual. Then we'll do the broadside. And then finally element 2. Now I like to give each wire a little tug when I'm done tightening it down to make sure that I got it right. Now before I do that last one, I am going to go ahead and screw this board down. And then now we're ready to do the power switch, which should be the top pin, which is the red wire we soldered on, followed by the white wire for the LED negative, then the black wire for the LED positive, and then finally the blue/purple wire, giving us a finished board that looks like that. That's not too bad if you ask me. Next up, we'll test it before we put the lid on. All right, now all we have left to do is power it up and make sure that the board is working. First, I like to use a multimeter. And I just test between my positive and negative of my voltage input to make sure that I don't have a reading. That makes sure there's no dead short before I power something up. The kit comes with a pigtail for 12 volts, so you can use your power supply in your shack. So I'm going to try to do this backwards so you can see it. So we'll turn on the power, push the power switch, and we have power. If we put it on element 1, the element 1 LED should come on, the broadside LED, and element 2. If we use our multimeter and put it on 12 volt, on element 1, if we probe pin 1 and pin 6, we should see 12 volt. If we switch to broadside, it should go to 0, and pin 2 and 5 should have 12 volt. And then if we go element 2, pin 3 and 4 should show 12 volt. And it does, so the board is good. So now we can continue by putting the top on. And there we go, the array controller is assembled. So the finished product turns out really nice. You have a good aluminum case, metal switches, nice connectors. I like the fact that it uses the terminal strips. It makes servicing in the future easy if you need to. Now we'll get started on the relay board. So anytime I do any kit, I like to always start with the smallest components first. So we'll start with these diodes. You want to put the stripe in where the box is, facing towards the relay. Take our snips and trim those off. Next we'll mount the capacitors. That looks good. And let's go ahead and do our connector. Check all of our solder joints. They look good. All right. Next we'll do the relays. Now notice on these relays, they are different. There's a 6-pin and an 8-pin. So make sure you're inserting the correct one. You could put the 6-pin in the 8-pin, but you can't put the 8-pin in the 6-pin. So it is possible to get one of them soldered in wrong and be like, oh no. Now John also mentions that you can use painter's tape at this part, but if you just be careful, flip them over, you can set the board down in the way to hold them on their own. It's just whatever you prefer. It's probably time for a new tip on my soldering iron, but we're about done. Once I tack those, I like to make sure that they're straight and then finish soldering them. Inspect your solder joints again. And then we'll mount the 3 LEDs. On the LEDs, the longer of the 2 legs is the positive lead. And the positive lead is going to go into the square hole. So you'll have a square and a round. So put the longer lead, I don't know if you can see that, in the square hole. Now we've assembled the board. I'm going to use this as a holder while I solder it. Now we'll use the leftover wire from the controller build for this plug as well. Now remember, you don't need to strip too much wire, or don't need to strip it too far. Just a little bit so you can solder it. That way you don't have to worry about wires touching each other and shorting. Now this is the same color code as with the controller, so we'll put the brown wire on pin 6 first, because it is the hardest one to do. And then we'll start with pin 1. I'm going to put that connector on there so it holds it in place and quits moving all around. And then black goes to pin 2. Green goes to pin 3. Blue goes to pin 4. I should tin these. Keep forgetting to tin them. Makes it so much easier. And there we go. If you want, you could always run a little bit of heat shrink tubing down on these wires to give it some insulation if you're worried about anything shorting out like that. And then you can just heat those up. Gives you a nice connection. Now I'm going to cut all the wire ends off at equal length. Now we're going to take our SO239s and put in the board. Alright, so with your bracket with the short L up, you want to bring your connector up, put your metal washer with the teeth facing down, and then if you look at the nut, there's a flat and a beveled. Put the flat down so the beveled is up. Just kind of snug it just a little bit, but don't make it tight right now. We need it loose. Then you can go ahead and put the standoffs on. I just barely tighten those as well. Now with this kit, you don't have to follow the instructions 100%. If you're an experienced builder, you can move around and you know how to put kits together. But one thing that you do not want to do is you do not want to tighten these SO239s until you have the board fit in place correctly. And we're actually not going to even solder them in until we test it. The reason being is because it is such a tight tolerance, and it was done that way on purpose, that you want to make sure that they fit before you tighten them down. If not, you're going to have trouble fitting your board. And if you have those locked down and you've already soldered, then it's going to be a mess. So just make sure you don't tighten those down until you have the board fitting correctly the way you need to. And you want these to be very tight because you don't want it to be a big hole and it's just moving around with solder. You're going to risk solder breaks in the future. So just take your time. Something I probably should have done first was mount this connector to it, but it's not too big of a deal. I can still get it in there and tighten it up. Now I'm going to guess these wires, and I actually might trim them up as I go. Make it really nice. Should probably start with pin 6, which is the brown one. Now remember, you just need a little bit past snug. You're not trying to break these things off. And then the blue wire is going to go to pin 5. Then the white wire goes to pin 4. The green wire will go to pin 3. The black wire to pin 2. And then finally the red wire to pin 1. And then it should look like that. Now we want to test the board before we solder these in, just in case we need to remove the board to do any repairs. It's much easier. Now that we have the control cable hooked up to the controller and the relay board, we can power on the controller and test the relay board to make sure it's assembled correctly. Using a multimeter, you want to set it to element 1 on the controller, and you should see continuity between radio and element 2 on the relay board. If we switch it to broadside, we should see continuity between element 1 and element 2. Now that we know the relay board is good, we can solder the SO239 connections. And now we have the relay board finished, we'll mount it in the enclosure. The kit comes with a really nice outdoor enclosure. So you'll want to mount it so it's lined up with the slot at the top of the box. Take the 3 provided screws, the short screws, not the ones that come in the box, and just screw the bracket down. Then we have the mounted relay board. The only thing left is, let's put one of the stickers on the board so everybody knows what we're working with. We'll put it, I think, right in the center. And that looks pretty good. A completed 2-element phasing array kit. Make sure to subscribe because in the next video we'll deploy the antennas and install the kit and test it on air so you can judge the performance. Thanks for watching.